Hello, everyone, and thank you for joining us for this edition of Community Conversations, our Technomatics virtual user group. My name is Taryn Blake. I'm the Community Engagement Program Manager for our DISW PLM community, and we are here with another session. Today's topic is how to create a sequentially working worker. As many of you know, our speaker for today is Mr. Stefan Bongso. Stefan is a freelance simulation expert who has been in this space for many decades. He has 5 books completed on plant simulation, and he definitely has a 6th book on the way. He's done many training sessions with us, and he is a leading contributor to our Siemens PLM community and a community catalyst. Our topic for today, let's move to the agenda. As you can see, 2 big steps here will be about writing the bill of process and then programming an importer request control for the broker. We also, with all of our sessions, Stefan will be presenting completely live, and we will have a live Q&A after the presentation is complete. So you are welcome to type some questions in the chat as we go, but you're also welcome after we complete the presentation to use the button to raise your hand. It should be in the middle upper menu on your screen. You can raise a hand and we'll be happy to take you off mute to ask your question by your voice. But yes, that is all for our introduction right now. And give a thumbs up if you can hear me. And Stefan will change the screen and begin. Thank you.
Hello again to a new session in our webinar series. And our today's topic is about the worker and another way to organize or to control the worker if he has to do a sequential work. And today we make as one example a multi-machine operation where the worker has to load and unload several stations with parts that have different work plans. And so we first create our scenario for the day. We have one source. I change here the station in 3D so we can see the caption, the names of the station. And so we have several stations, station 1, station 2, three and 4. And I need a buffer. And this buffer I connect with the train. So all these station needs to have a workplace, and so we add for the source and for all the stations here a workplace and activate the transport importer. And we need one walk plate at a buffer, but we don't need to activate the transport importer here. It's only at the final destination for the parts. If you don't work with version 2404, you need to activate the transport importer by yourself. So please make some tests here. You need to activate transport importers for the source and for all stations. Okay. And then we need, of course, one broker. And we need a worker pool. We can let the worker pool in the default settings. We don't need to change something here. This is our basic scenario. One worker needs to load and unload 4 machines. And on the machines, we have to produce several types of parts. And the worker is alone in this area. And so we need, as a next step, to set up some parts. So I need to duplicate here one part. I want to add a user-defined attribute. I need to follow a plan, and so I need to store some sequence position in the part. And so I create a new user-defined attribute of type integer with the name seqpos, and the initial value is 1. Okay. And then I rename this part to part 1. And duplicate it 2 times and rename the duplicates in part 2 and part 3. All parts have the same user-defined attribute. And to make it more visible, I changed the color of part 2, added 3D properties, tab appearance, and activate the material, and I change another color, red for instance, and part 3, same appearance, activate the material and select one color, maybe blue. Okay. Next, we need to set up the source that it creates these 3 parts, maybe randomly. And so I need one table, one data table. And I set this here random, and I want to have this data table here as data source for the sequence of parts. And this is quite easy. Drag the 3 parts here into this table. And the frequency should be 0.4, 0.4, and 0.2, for instance. And it should create one part each. This is now my basic setup for this model. As the first step we had in our agenda is I want to create a bill of process for all three parts in a special way. I want to use a nested table for this. And so I need a second data table file here, and I name it bill of process, VOP. And we need to format this table first. I want to have a row index. These are the parts. Part 1, part 2, part 3. And here I want to have the bill of process, the work plans for all parts here. And so this should be a table, format table. And you need to set the format of this subtable in the tab contents. And I want to have in the first I want to have the column index. In the first column, I want to have the station. The second, I want to have the proc time. Oh, station needs to be object, and proc time is time format. Okay, and now I can create the first bill of process here. For the first part, maybe should be a station 1, and then it goes to station 3. Proc time 2 minutes and 3 minutes, and finally it should go to buffer. And here we don't need proc time. And so I can create a bill of process. We need to create a bill of process for each part. So we can copy, for instance, this here. Part 2 should only go to station 3 for 10 minutes. And then to the buffer. But you can check yourself. You can make your own plans here. And part 3. Needs to go to station 2 for 1 minute. Then station 4. 3 minutes. Station 1. $12. Station 3 for 2 minutes. And finally to the buffer. And if you want to have really fun, then let it go back to one station, maybe 2 times to station 4. Okay. Now we need to organize the flow of these parts here, depend on their plans through this production. And we had already 2 webinars how to create such behavior in the simulation. You can do this in the exit controls of the stations here. We need to increase one order number, for instance, in the MU, and then you can look into the bill of process of the parts. Where's the next place? And then you need to wait until there is the station 3 here, if you don't have interim buffer. And then you can move the part to the station here. One step we need exit controls here into the stations to increase the user-defined attribute of the part. But this is quite simple. We need a method. Maybe a station exit control. And here we need to increase our user-defined attribute. And we need to call add move, and add move will call the worker if we need one, and this will activate the broker for mediate the worker. And this is the exit control of all stations. And so I just drag it on the stations here. Okay, another way to control this flow is to use the broker. And the broker, in the broker, we can create a control where the broker is just look if the next station for this part is empty, and then mediate the worker to the transport job. If not, the broker should do nothing. And for me, it's like a brute force method because every time one station will finish the job, it will call the broker, and the broker will do in many cases nothing. If the worker becomes available again, then also the broker will be called, and it will check if there are open requests, and then mediate this, the broker if it's possible. And so we can use this this behavior to control the complete flow inside such multi-machine operation cells. And so we create a broker import request control. just by pressing F4 here, or you can use this one and create control. And it's quite lean in this in version 24.04. But if you need a more complex blueprint, you'll find something here, and if you need another template, you find here another template for the broker importer request control. It's enough for us here. I need to first to look what's the next station for the part. I want to have a variable for this of the object. And I find the next station in my bill of process table. I have only one column, and the row is object. It's the importer here. It's the source or one of the stations. And with cont, I get the part on it, and name is the name of the part 1, part 2, part 3. And the objects are in the subtable in the first column. And the next step is here, after calling the exit control, part seek pos. And then I have only to look, okay, if my next station is occupied or not. If or if next station point false. I want to transport the part with the worker, so I need to set the attribute destination. To next station. I need to set the proc time. I copy here this stuff. The proc time is in the second column. The same row like here, the next station. And then I need this standard command from plan simulation, do standard import, and this will mediate the worker to this job. And there's no else. If the next station is occupied for this importer, then the broker import request control will do nothing. We don't import a worker, and this control will be called if the next importer is free or if the worker becomes available again. And so we can organize the controls starting with the next free successor. And that's it. it's quite simple from the programming, and now we can make a check. Oh, this is bad. Okay. Now I write in each station here one default target, maybe buffer. I'm sorry, I don't tested this with 2404 before, and so
Someone in the comments was curious if it matters that it says wait for free target in the source, if that makes a difference.
Oh, yes. Can also make a difference, yes. One moment. And is this active? Yes. Oh. But we shouldn't start here. Okay, it could make a difference, yes. Maybe we need to deactivate wait for free target in each station. Okay, let's try it again. Yes, it makes a difference. Thank you for the advice. Yes. And now our broker request control will control all the movements here. The first with a free successor will get the transport order. And if there is no successor free, then it just calls itself again and again. And so you don't need a very complex control to solve such kind of tasks. And if you want to make optimization, then you need to optimize the order here, the order of the parts that the source is created. Okay. Questions?
So someone asked, what's the difference between destination and MU target?
Destination is one attribute here in the part. It's depend on it's here in the tab routing destination, and with destination you can set the destination if you don't want to use the default the setting here in the importer transport MU target. Plan simulation will transfer this to the MU if you don't have any programming behind. But you can set instead of setting here a fixed MU target, you can set the destination of the transport, for instance, using exit control in the station. Or like we done it here in the program, importer request control. The latest point in time where you need to set this destination is before you load the part on the worker, because the worker will transport the part to the destination that you set here in the part. It's only two different ways to set the destination of the transport of the worker. And this destination attribute you can also use if you use automatic routing for the parts through conveyors, for instance. Then this destination will set the final destination for the transport. And if you have HEV, then and you set the destination here, if you have a HEV that is not free moving, then this destination will start as the HEV if you set this. So this destination has a lot of functions in plan simulation, this destination attribute. Can you give an example of the most complex application of Technomatics that you might have seen? Yes. I have my most complex models are paint shop model with more than 20,000 conveying elements. If you have ever seen one of my presentations, then I have shown a lot of examples from body in white production lines, and I have done by myself body in white lines with more than 300 robots, and this is quite complex. But there are so many complex models out there. So I don't know the most complex application of Technomatics. I don't find until now a limit for this. How would you make a station that needs to be processed by two different operators or has two different operations, each one with its own process time? Oh, we have already done this in one of our webinars. You need to look into the, we have a site in the forum where all the webinars are available, and we had already this webinar. You can have several operators here, two different operators, not really difficult. You only need to set two services here. It's for transport not possible if you have activated processing here. And here can services, you can set two services here, two different services with the amount of 1 and 1, and then you need both of these services to start the operation, but it will take the complete processing time. And if you want to stop one of the processing before it's finished, then you could stop the processing with stop processing. It's a command here, and then start the next sub process for the second one. It's not so easy.
So it looks like the next question was from Hala. If the worker needs to process the part at the station and also do the transport between the stations, how can I make the worker stay with the part and not get called for other tasks?
Okay, you can bind the worker to a part. This was also one of our previous webinars. It's worker accompanying I guess was the name. Another way would be to use special services, that you have one service for one worker, and the worker has to the station needs to set the special worker service. It could you could name the worker here, maybe Tom, and then processing and transport needs the service Tom, and the worker Tom only offers the service Tom, and so only the worker Tom can do these services. This is the easiest way and default way to solve such problems in plant simulation. But another way could be the worker accompanying, I don't know how to spell it right, pronounce it right. This would be to switch off the automatic mediation of the worker and mediate the worker if you need them, the special worker, and you can do this with here with the request control. But you find this video in our video collection already.
Yeah, I've dropped the links to some of the worker videos specifically. So the single flow worker accompanying is in the chat. The direct link, random worker behavior, making a 3D worker sit at a workstation, part transporter and worker tracing. They're all there in the chat, and you can find the entire library at the link that was in the chat earlier. So that's really great. Let's see, the next question I saw was asking, we need to set the destination MU target before calling the worker. It's kind of like yes or no.
Yes. Otherwise, you get an error message that you don't have specified a destination for the transport. So you need to set it before you load the part on the worker. Yes, in some simulation, we use workers. I'm also use shifts. I would like to ensure that the workers return to the stations where they were already working in the previous shift. If you have only one shift, then you can also, you need, okay, there are a lot of discussions in the forum about this topic. So you can search a topic for this and you find a lot of approaches to solve this problem. Otherwise, you need to remember, and then you can send the worker with go to the next station, but you need to mediate the right worker. And so the easiest way would be to use special services. This is the easiest way. And so it's like Tom. And so Tom will only mediate it to Tom machine. And so you can bind the worker directly to one machine if you need to do this. Is it possible to set a data table as the destination for an MU? With automatic routing, plant simulation takes care of the routing without the need of any methods or import request control. Yes, you can activate the automatic mediation for the part, and then you need to set a list as a destination. You can find more in the help for destination.
What it should be showing you right now, okay, good. What it should be showing you right now is a screenshot of the actual form page. You can also click the link on your screen. It will take you to the page that is being shown. At that page, we recommend that you click to follow the topic, and then that you click the icon, envelope icon, to choose every post for the email notifications. The reason for this is that the only thing posted in this area are the recordings and registration links And if Stefan ever runs out of topics, he'll ask, suggestions for topics there. But it's very narrow. It's only for plant simulation tutorials. So that's why it's a virtual user group. And you can also ask questions later about these videos. So the videos are posted there. You can post questions underneath the videos, share code snippets, share models. It's very valuable. So we strongly recommend going there and then clicking follow, clicking every post. So I think that's good. And then you'll see on the left-hand side, of course, our next two topics are going to be on AGVs. So collision control basics, custom heat mapping, and Stefan has already done a basic intro to free driving AGVs. That recording is in the forums, and this will be one of our other super users doing these next two topics on AGVs. So that is basically the forums there. There's still some time to get in some questions if you have any. I do see a comment in the forums talking about Stefan, I guess, saying that your approach makes it easier to implement alternative flow. So sounds like a good thing. I do want to call out the screen that's up right now as well. There's a link on here, this screen, to Stefan's profile in the community. So if you click through the app mentioned, you can see a little bit more of Stefan's contact information. And this recording from today will also be back in the forums that we've been talking about on Friday. So this recording will be there available to you on Friday.
And also the model.
Yes, and the model. So there is a question. Two just came through.
Yes, a student version don't have the interface package, and for MQTT you need an interface package, and so you cannot use it.
And then secondly, could you explain the same simulation using an AGV instead of a worker for the future? It's a big question.
Yes, it would be more complex because you don't have the broker and the movements you have to program by yourself. If you needed a worker to empty a buffer onto a conveyor next to it using a transport, can you make sure you keep using the same worker since each MU would trigger the program again? It's the same. You can use the services to assign this to a special worker. You can change the service of the worker in each time. And also you can change the service table of the transport importer dynamically to call one special worker and keep calling the worker again and again for all the transports you want to do. So you can change the services table dynamically. And this is quite, it's a secure approach to do this.
Okay, so we got to thank you for that. Good. And I just want to say thank you for another really great session. We can tell by all the questions that are coming through that this was really appreciated.
Thank you. Keep informed. There will be more topics with workers. And yes, until the next webinar.
Yeah, we'll see you all next time. Bye, everyone.
Bye.